Another one of the aiming for grade 9 papers, and we've done paper 1 and 2, so now we're going to do paper 3. And one thing I wanted to say just before we get started is that, technically speaking, on your spec, there aren't paper 1, 2 or 3 topics. They can appear in any paper. However, paper 3 tends to be a lot more based on stats. But just so you're aware, it doesn't necessarily have to be all stats. Right, the stats can appear anywhere. And I think we should start from the end like we did last time, for the last 2 times, because I think it's... we can start with the harder questions then, right? So, if we have a... Oh, God. All right. Maybe we should start with question 1. No, I'm kidding. Okay, so we have a circle here. We have 2 circles that are overlapping each other. Okay. And we have a triangle in the middle, and we need to prove that CAB... Okay, so where is CAB? CAB is over here. Is equal to ABC, which is over here. Okay. Cool. So, what I'm going to do here is, since we don't know what CAB is, I'm just going to call CAB X. Because I don't know what it is, so generally speaking, unknowns are just given letters, so X is as good a letter as any. And the other thing that's making me kind of suspicious is this thing here, ORCA, if I were to draw a line here, is a cyclic quadrilateral. Right? And it actually tells us that in the question. It says ABRC are points on the same circle. It's not that one. It's ABRP. Yeah, my bad. So that means it must be a cyclic quadrilateral. And the reason why that's important is that opposite angles on a cyclic quadrilateral add up to 180. So that means this angle here should be 180 minus X, right? Does that make sense? I hope so. Now, if I actually look at this, O to R and O to B are the radius of the circle, so they must be the same. Hey, Ice Cream, I'm well, thank you. How are you? And yeah, and hopefully you can see that O to R and O to B are just the radius of this circle here. Which means this is actually a big old isosceles triangle. Okay. Now we can work out this angle here, because angles on a straight line add up to 180 degrees. So what we're going to do is do 180 minus this angle. So we have 180 minus, so actually let's expand the brackets to make it super transparent. Minus X, we get plus X. These 2 things cancel. That means this angle here must be X. And because it's an isosceles triangle, this is also X. Which means we've shown that they're the same. Now, it says prove, so we're going to write a few kind of words out. We're going to say that CRO equals X. Because opposite... Sorry, it doesn't equal X. It equals 180 minus X. Because opposite angles in a cyclic quadrilateral add to 180. Then ORB equals X, because angles on a straight line. Are there any questions about this while I write this up? So just let me know, and then we can go through it in a bit more detail. Angles on straight line. Can a cyclic quadrilateral be in an oval, not stand a circle? No. So it has to be on an actual circle itself. So when I said cyclic quadrilateral, I didn't mean this kind of oval shape here. I meant that, can you see A, O, R, and P are actually points on this right-hand circle. Sorry, not O, P, the other ones. Okay. So hopefully that makes a bit more sense. So they're all points on the left-hand, on this circle here. So it's not necessarily in an oval kind of shape. And then lastly, OBR equals X, because isosceles triangle. Okay, so that would be the reasoning. It's 4 marks. So you get 3 marks for kind of the proof and the statements, and then the final mark for just saying hence hence RBO is equal to PAO, or however you want to word it. CAB, I think they used. Well, that was fun. The question I gave you last week as well, your method was so long. Hey man, I'm doing my best, okay? Okay, so truncate. This is something that doesn't really come up that long. You did it again, didn't like 3 steps. Fair enough. There probably was a faster way to do it, it's just that I did it. Hey Hybrid, how are you? For this question here, it says aiming for a grade 9, but this is actually a word they expect you to know in your spec, but not a lot of people know it. I did go through it last week, but there's a few new faces in the chat at the moment, so I want to go through that one more time. So there's 2 different types of rounding, so to speak. You have rounding, then you have truncating. To truncate something means to just remove the decimal. And when I say remove, I mean you literally just get rid of it. So if I were to round 6.7 to the nearest whole number, you would say it's 7, right? Cool. When I truncate it, all I'm doing is crossing out the 0.7, so my answer would be 6. So in this question, it says Martin truncates the number n to 1 digit. The result is 7. Write down the error interval. So you always put the letter in the middle. Now the biggest this could possibly be is 8, right? And by that I mean the biggest it can be is 7.9 recurring. And the smallest it could be is 7.0 going on pretty much forever and then a 1 at the end. So your error interval would look like this. Neither of them are going to be... So in this, normally you might have like an equals on this side, but in this one it's on this side here. Because it can be 7 or above, right? And both of those would truncate to 7. Because again, when you truncate something, you literally just cross out the decimal. You ignore the decimal. So it can either be 7.0 going on forever, or it can be 7.9 going on forever. Anywhere between those 2 values. Any questions about truncating? To be honest, I imagine it's a word you just haven't heard before, but it's actually relatively easy after you go through it. Any questions? No? 9? Okay, speaking German now. Interesting. No questions? Perfect. Okay. So, to be honest, this is actually not too bad so far. Alright, never mind. Spoke a bit too soon. It wasn't too bad so far. So S is a geometric sequence. So just for those of you that may not be aware, a geometric sequence means it's multiplied by the same number. Each time. Okay? Good God. Yeah, but all you have to worry about, this is on your mock. Well, we're about to figure out, I think this may have been on the mock at my school, but I'm not sure. What sequences do you need to know? That is a brilliant question. You need to know sequences of triangle numbers, square numbers, cube numbers, good old Fibonacci. You need to know arithmetic, quadratic. I think that's it. I'm pretty sure that's it, unless anyone can remember any more. So yeah, triangle numbers, square numbers, cube numbers, Fibonacci, everything. To be honest, I think triangle numbers is one that a lot of people haven't seen. First 80 triangle numbers. Jesus. It's madness. I mean, you're not wrong. The Fibonacci sequence is something called the golden ratio. So they do hang it in classrooms a lot because it's like maths in nature. A Fibonacci sequence actually appears everywhere. For example, the shell of a sea snail is a Fibonacci sequence, as an example. But yeah, those are the sequences you need to know. But with a... Sorry, not a quadratic. I meant geometric. The other one is a geometric. And a geometric sequence means you're multiplying by the same number each time. So what they're saying here is to get from root x minus 1 to 1, I multiply by something. And to get from 1 to root x plus 1, I also multiply by something. So in this case, if I need to work out what x is, what I can do is say that root x plus 1 divided by 1 should equal 1 divided by root x minus 1. Right? Because they're multiplied by the same number each time. Which means if I divide them, they should give me the exact same value. So this left-hand side is root x plus 1, and that would be 1 over root x minus 1. So it was pattern transition, yeah. I couldn't spot the pattern for so long. Yeah, some of those are tricky, I'm not going to lie. So how do I solve this? Well, again, I'm just going to rearrange this quite naturally. So I'm going to times both sides by root x minus 1. Both sides. So we're left with root x plus 1, root x minus 1 equals 1. So root x times root x is x. Root x times minus 1 and then plus 1 times root x is going to cancel. So it'll be x minus 1 is equal to 1. So x is just equal to 2. Yeah, they come back a lot in A-level maths. So I could actually show you the A-level maths equation for it, because it can help in situations like this. But yeah, geometric is part of your spec. And that's what I mean. I think triangle numbers and geometric sequences a lot of students tend to forget about. Followed by Fibonacci. Those, if you want me to go over any of these quickly, let me know. But I'm going to assume it's okay for now. Part B says show that the fifth term of the sequence is 7 plus 5 root 2. So there are two ways to do this. One of them is using the kind of A-level equation, because bear in mind, this is paper 3, hence we can use our calculator. So I can show you the A-level equation. Go over geometric sequences. Yeah, so this question is geometric, and basically the special thing about geometric sequences is they're multiplied by the same number each time. Okay, so that's why I did this division over here. Because if I take this term and divide it by the previous term, that should be the same as this term divided by this term. Because to get to each of these, they've multiplied by the same thing each time. Which we didn't actually end up working out. But yeah. Well, actually, no, we did. It's root x plus 1. That's what they divide by each time. So I hope that makes a bit more sense. So yeah, the common ratio, they call it. So the thing we're multiplying by each time is root x plus 1, which we just worked out is root 2 plus 1. Is that all okay so far? If so, the two ways we can do this is if you want to work out the fifth term, we can work out the fourth term and then work out the fifth one after that. So the third term is root 2 plus 1. So if I multiply that by root 2 plus 1, was meant by maths textbook generally. It's just a book that helps teach you maths by going through text, so describing it in words, and it should have some questions in there as well. So this would be the fourth term. And again, don't be too scared because this is a calculator paper, which means we can just use our calculators. Shocking, I know. So that's 3 plus 2 root 2. And therefore the fifth term is going to be 3 plus 2 root 2. And again, times by the same number. I do not trust calculator for certs at all. Why not? Calculators are fine. Right? So I can just use the answer button, so just times and then whatever the value is, so root 2. As long as you use brackets. If you don't use brackets, then surds are going to be your enemy. But if you notice, I always use brackets. What is the A-level equation? I'll go through that right now. So this might look a bit tricky. However, there is an nth term equation which you learn in A-level maths. And this is what it looks like. It's very short, but very powerful. It's A r to the n minus 1. Is paper 3 actually the hardest exam? I don't really understand why it's multiplied by... I don't really understand why it's... Okay, so I'll go through the questions now. So, first things first. From the beginning, a geometric sequence is a sequence where you multiply the terms by the same number each time, right? So for example, this could be a geometric sequence, right? And then 16. Because if you divide each of these numbers, right, can you see I'm just timesing by 2 each time? But how would you actually work that out? Well, you'd work it out by just dividing the numbers, right? So that's quite an easy example. But to work out what the multiplier is, you would take this term and divide it by the previous term. So 16 divided by 8 gives me 2. 8 divided by 4 gives me 2. 4 divided by 2 gives me 2. 2 divided by 1 gives me 2. So can you see that to work out what the kind of multiplier is, you just take one term and you divide it by the previous term. So in this question, however, we have a bunch of algebra. So to work out the multiplier, I did root x plus 1 divided by 1. So I know I'm timesing my equation, or my terms, by root x plus 1. Perfect, okay, good. I'm just going to read through it again. Is paper 3 actually the hardest exam? Some people think it's the hardest because they never practice it in schools. But no worries, Maya. Okay. This here is an A-level equation. So you might be wondering why on earth I'll be showing you this now, right? And you'd be correct. But the reason why I'm showing you this now, and actually for some of you are quite new, but those of you that have been with me for a while, when I do arithmetic sequences, I also show you the A-level equation, because the A-level equation makes it very easy to work out nth term and work out any term in the sequence. So the A-level equation just says that this is the first term, A is always the first term, and this is your multiplier. And n is just like what term you're looking for. Okay. So if I look at what my first term is, A, it's root x minus 1, but I already know that x is 2. So in this question, I'll just do root 2 minus 1. My multiplier is root 2 plus 1. Whoops. To the power of, I'm looking for the fifth term. So that's 5 minus 1, which would give me the exact same answer here, 7 plus 5 root 2. So again, that might not look too useful to you now, but even with like arithmetic sequences, and again, for those of you that have been with me for a while, you've probably seen me use the A-level equation a lot. But yeah, I do tend to use it quite a bit. Yeah. Could you give an example of using this formula? So if you use the A-level equation in the exam, you can still get the marks. It's completely fine because it actually looks indistinguishable from the mark scheme. Because yeah, so this is totally fine. The only thing that you can't use from A level in GCSE is something called differentiation and integration. If you don't know what those words mean, that's good because you can't use it. But there used to be a case about 5 years ago where you could use A level differentiation to work out certain questions in GCSE. Yeah, you can use this on a calculator, yeah. So, I mean, if you want, you could even do like with this equation here. So, first time was 1. Prime does equal differentiated. Wait, as in use the equation on a calculator, or do you mean like do the sequences on a calculator hybrid? Yeah, if someone says like x prime or something, that means it's been differentiated, yeah. I guess you could say alpha prime, yeah. Generally, the apostrophe means differentiated, yeah. But you're not allowed to use that. Yeah, sure. So, if I take this as an example here, A in this case would be 1, right? Because it's the first term. My common ratio would be times 2. And let's say I want to work out the fourth term, so this one over here. Then I'd say n equals 4. If you remember, my equation was AR to the m minus 1. So I do 1 times 2 to the 4 minus 1. Again, this might be a relatively easy example, but you can do it. So if I open the calculator, and you get 8, as we expected. Why do you use that in trig? Why do you use alpha in trig? Normally you use theta and phi, but sometimes they use alpha, especially in kind of like the Cambridge exams. As for why, I'm not 100% sure. I think it's because alpha and beta just mean 1 and 2 in Greek. Prime. I'm not sure. I mean, it might be that it's like a changed coordinate system. It depends on the context, because what it might have been is that it's an angle that's changed. Anyways, let's keep going through this, just in the interest of time. See if we can get through a lot. Do I teach GCSE? Not currently, because I haven't really had anyone that's requested it. So not quite yet. Vic? Yeah. I don't teach it just yet, because again, no one's really asking for it. So this question, we have something that looks pretty hideous. So it looks like a bunch of squiggly lines. It tells me that A, B, C, D is a parallelogram. Okay, cool. Which means that these two sides should also be parallel. Oh, it already has that on there, but I'm going to leave it there just for my sake. It says, prove that angle ADP is congruent to CBQ. So ADP. And what I'm going to do is I'm actually going to draw out the triangles for like all of our sakes. And this will just help me label, kind of explain exactly what we're doing. Can you put the PDF of these questions in the description? Absolutely, I can. Yeah. And the other triangle looks like this. So these are the two triangles we're looking at. I hope that makes a bit of sense. And what I'm going to do is I'm just going to label what bits are the same, because it's kind of hard to see on this diagram. So, first things first. Can you also put the mark scheme? Yeah, sure. I'll put the mark scheme, and in fact, yeah, as soon as the live stream's finished, I'll put it in there, so then you can just quickly check it. But I'll put the PDF of the questions and the mark scheme in there. So first things first, can you see that these two sides here, AD and BC, will be equal? So AD equals BC, because opposite sides in a parallelogram. I saw your point, Evie, I just haven't read it yet. I saw... So can you use a right angle for SS? You absolutely can. So when we're talking about congruency, what you're looking at is things like SAS, ASA, not three sides actually, but actually no, three sides would work as well. So SSS and RHS, right? And you can use, so the A stands for angle, the S stands for sides. This RHS, it means it's a right angle triangle with the same hypotenuse and one side the same. You can use a right angle for the A bit, which is actually what I was planning on doing, because I've realized it's going to be hard to work out what the hypotenuse is, because we'd have to prove that AP is equal to QC, which we don't know yet. But we know that these two sides are equal so far. Okay. However, so the opposite angles here should also be equal to each other. So what angle is that? That's DAB. Sorry, DAP even. And the opposite one will be BCD. Yeah, this one here. So how would I word that? I'd write that as DAB is equal to, God, I'm really having trouble here, DCB. And the reason for that is because the opposite angles in a parallelogram, angles are equal. So it looks like Evie might be onto something here. ADP and QBC, they're both right angles, so they must be the same. So here, can you see that we have two angles and the same side that are the same, so we're going to be using ASA. Again, technically speaking, you can use any of them because they are congruent, which means they should be the same. But I'm going to write QBC is equal to ADP. I'm just going to say right angles. So in this case, it's ASA, they're congruent. Could you use RHS? Yeah, so because it's a right angle triangle, you can use RHS. I would like to point out that you can always use all of them, except obviously the right angle one, because some triangles aren't right angle. However, you can use any of these. The only problem that I personally would find is that you'd have to prove that AP and QC are the same, which I don't think is the easiest thing in the world. Right, because that's the hypotenuse. The hypotenuse is QC and AP. So ASA would be the one I would have personally chose. Is a trapezium one set of parallel lines? Yes. Parallelogram, you have both sides are parallel to each other. Trapezium, only two sides are parallel. The other two aren't. Okay. I'll have to draw this out, sorry. It's co-interior angles. So this angle, these two added together would equal 180. Right, so x and y, x plus y is 180. And same on the other side, except the angles might not be the same. But you just use co-interior angles for that. Okay, and for part B, it says, explain why AQ is parallel to PC. So AQ is this side, and PC is this side. So probably the easiest way to talk about this is because they're congruent, right? So, yeah. So AP is equal to QC. Because the triangles are congruent, so they're the same. Again, I'm writing a bit like a caveman just to save me a bit of time so we can get through as many questions as possible. So because AP and QC are the same, because again, remember these two sides of the triangle, these two triangles are exactly the same as each other, they're congruent, then that means APQC is a parallelogram. Which means AQ is parallel to PC because opposite sides are equal. Don't ask me why that took so long for me to figure out. Okay. Not too bad. Any questions at all? Could you also explain using corresponding angles? For part B. What's up, hybrid? No questions, yeah. Oh, as in show that the angles are the same, and therefore it has to be a parallelogram? Yeah, you could do that. Oh boy, vectors. Everyone's favourite. Okay, see, I need to lean forward, I need to focus on this, because vectors are always fun. So we have these, this, and this are all straight lines. AN is equal to twice OA. Cool. M is the midpoint. OA equals A and OB equals B. AP equals KAB, Jesus Christ. Given that NPN is a straight line, find the value of K. Okay, so a question that I sometimes get is, how do I use the information that 3 points lie on a straight line? And the easiest way to think about this is that vectors that lie on the same straight line are always parallel to each other. Lila, can I send you a maths question? Yes, absolutely. Let me stick my email address in the chat. So yeah, you can email me questions whenever you want. That's totally fine. Okay, vectors are awful. I agree. And these are grade 9 vectors, so they're even more awful. But the key thing to remember is the straight line bit means the separate pieces are parallel. Okay? So if 3 points lie on a straight line, then MP and PN are parallel to each other. Okay? And what does it mean when two vectors are parallel? Well, it means that MP is equal to a scale multiple of PN. Now the thing is, they've already used the letter K, so I'm just going to pick another letter. I'm going to pick Q. Okay? So I know that NP is some multiple of PN because they're parallel to each other. We need to find AB first. I think you're correct there, hybrid. But so far, is that okay? So whenever you see straight line, it means the separate pieces of the three letters are parallel to each other. So MP and PN are parallel. And if two vectors are parallel, they're scale multiples of each other. Now, in my opinion, mark schemes for vectors are really bad, as in they don't explain things very well at all. So I'm going to show you a method that might look a bit longer, and then I'll show you the shortcut. Okay? The shortcut is what the mark schemes use, but I'm going to explain it fully, which means we might take up quite a bit of space, but then I'll show you what the shortcut is, okay? Which again is what the mark scheme uses. What they tend to use anyway. So far so good? If so, I hope so. Okay. So, how do I use this information now? Well, what I'm going to do is I'm going to find... you're cool, perfect. What I'm going to do then is I'm going to find a method of... Cool. Also, by the way, it does also mean that MN is also parallel. So if we're stuck on MP, we can actually work out MN. Could you post a link to the paper? Yeah, sure. Actually, I'll do that now. Why not? So this is the paper here. Okay. In case you want to like follow along or like do it in your own time or whatever. So, I'm thinking now, would it have been better to do... Okay, there's actually one thing I've thought of. AP is going to have a scale quantity in it, so it might actually be better for us to do MN as well instead. Okay. You go MP then MN. Yeah, so you can actually work out, depending on what you want to do, right? Like, it doesn't actually matter which kind of two letters you pick. So MN is also parallel to PN. They're all parallel to each other because they lie on the same straight line. So what we're going to do is I'm going to work out what MN is first, separately. Now MN, to go from N to N, M to N, I need to go from M to O, and remember, this vector here is A. No, it's not. It's B. And that's going this way. And this vector here is A. How do I know that? I'm just looking at the question. So I need to go in the opposite direction to the vector B, and it's only half of B. So it's going to be minus a half B. Because I go from M to O, which is halfway between this, and then I go from O to A, which is just plus A, and then I go from A to N. Now A to N here is 2O to A, so it's plus 2A. Okay? So I have 3A minus a half B. So hybrid half B plus A. Not quite. Not quite. Does that make sense for MN? So we're going to take this nice and slow because I know how painful vectors are. Any questions about that so far? Okay. Let's go just one more time. Nope, nothing. Cool. Yeah, I'd rather not wait for it then. Do we put this in brackets? You don't need to put it in brackets just yet. So this is actually totally fine. Why are we finding mn? Good question. So essentially, I want to use this piece of information here, that npn is a straight line, right? Now, what does that mean? It means that mn and pn are parallel to each other, which means they're scale multiples of each other. Since I have no other information, I have to use it, right? I have no other information. I don't know what else to do. So that's what I'm going to start with. We're going in the opposite direction. Yeah, so m to o, so it's negative half b, then plus a plus 2a. So if you go against arrows in vectors, you do negative. If you go with them, you do positive. The next thing I want to do is I want to work out an expression for Pn. So why am I doing this? Well, I have this handy equation here, Mn is equal to Qpn, but I need to actually work out what Mn and Pn are. That's why I'm doing that. So to go from P to N, I need to go from P to A, and then from A to N. Now, P to A is just a fraction of A to B. Is that clear? What fraction is it? Well, it tells me here AP is equal to KAB. So I'm going to write KAB out. And then I already know that A to N is 2 times A. Now the question is, what's A to B? Well, A to B, I have to go from A to O, so negative A, and then from O to B, which is plus B. So in other words, it's going to be K minus A plus B plus 2A. Expand the bracket, so I get minus KA plus 2A plus KB. Now, what I tend to do when I have vectors is if I have two terms which have A in it, for example, is I factorize out the stuff. So that's minus K plus 2A plus KB. Is PA not K? Not quite. Well, you've already corrected yourself, but yeah. So far, are there any questions at all? Again, this is a grade 9 vectors question, so if you're struggling, that's kind of the point. I wouldn't be too worried about that. You're lost? Okay, let's go through it then. I've made a small error. Since I'm going against PA, this should actually be a negative. So, Lila, you're actually correct. It is a negative. So this will be a plus, and that will be a negative here. I have made an error in that sense. How did you factorize on the PN part? Yeah. So let me go through that one more time because I did make a mistake. I made a humble mistake. So this part here. So how did I get that? Well, to go from P to N, if I break it down into steps, I need to go from P to A and then A to N. Right? Like if I just look at this, kind of like directions on a map. P to N, P to A and then A to N. Now P to A, eyes, P to A, looking at this, is just minus KAB. So minus KAB. Hybrid, is that okay so far? I hope so. Yeah, okay. So all I have to do now is work out what AB is. AB is quite nice because all I do is I go A to O, which would be minus A because I go in the opposite direction. And then O to B, which is plus B because I'm going in the same direction. I then just expanded it. Can't we find MP then factorize out the A and B? Understand? Cool. How did you factorize the second to last line? So how did I factorize this? Good question. So I can factorize this as factorizing out an a, and I would get k plus 2. With vectors, we tend to put the bracket first, however. That's the only difference I've done. Putting the bracket first doesn't change anything. Does that make sense, Lila? So all I've done is factorized out the a. Again, treat the letter A literally just the same way that you treat algebra. Yeah, okay, my bad. Fair enough. Okay, now here is where mark schemes tend to get really annoying, right? Because they do something which I consider to be really bloody annoying, which is they will jump straight to something along the lines of this. And then they'll just say solve. That is not the easiest thing in the world to look at, right? So just so you're aware, this is where you get your final marks from. You write this and then you rearrange. I'm going to show you how they get to this, okay? But once I've shown you once, you might be able to just do it yourself afterwards, okay? So, I'm going to get rid of that just for now. I'm now going to sub this all in to my original equation. So mn is 3a minus a half b. And that equals the letter q times pn. So if I expand this, have a look what happens. Oops. So I'm going to write that as q k plus 2a. So all I've done is I've subbed into that original equation I have. Is everyone with me so far? Again, I'm assuming when I wrote that mark scheme part down, and again, I'm assuming that that's generally what they do. It's very annoying. Okay. Now here's what they do. With vectors, the A components should be equal to each other, right? Logically. Everything in front of A on this side should equal everything on A in front of A on this side. Because it's gathering like terms, it's just basic, it's just algebra essentially. So you write compare A. Everything on the left hand side, which is just 3, should equal everything on the right hand side, which is q k plus 2. Right? Because everything in front of A on this side should equal everything in front of A on this side. Logically, right? And when I say logically, I mean because I've gathered the like terms, essentially. I do the same for B. Again, please let me know if there's anything wrong. On the left-hand side, we just have minus a half. On the right-hand side, I have minus q k. That's a simultaneous equation. The way you can solve it, though, the easiest way... First of all, who's unsure of that? Does that not make sense to anyone? There's a couple ways to solve this. You're not too sure, hybrid? So, from this line... So from this line here, I'm going to lower it down a bit, just to make it a bit easier to see. If I zoom in. You don't really get it, Maya? That's okay. So. Is that the simultaneous equation? Not quite. The simultaneous equation is both parts here. Right? So. I'm going to look at this. Right? If this was just like algebra, the coefficient of a on the left side should equal the coefficient of a on the right hand side, right? Because they're directly equal to each other. So everything in front of a should be equal on both sides. Does that logically make sense? So Maya, Hybrid, does that make sense to you guys? If not, I can explain it in another way. That might make a bit more. So that makes sense, yeah? Cool. So that's all I've written up here. I've written that both of those sides should be equal to each other. Right? So the 3 on the left-hand side is equal to the q k plus 2 on the other side. Okay. The next line down, again, use a green line, right? The stuff in front of B should equal the stuff in front of B here. And that's all I've written for the second line. Whoopsies, that's a bit too much. But yeah, gives me that. Does that make a bit more sense? And by the way, I've just noticed I can actually cancel out the negatives on both sides. So Hybrid Maya, does that make a bit more sense? Again, this isn't easy, right? So don't take it to heart. Yes, thank you. No worries, 100%. So solving this, you can do a few different things. You're very welcome. I don't know how to say you're welcome in French. Anyways. The way I would solve this, because I'm a bit of a maniac, is I would probably just rearrange this equation here. So can you all see actually that this is a simultaneous equation? Because both of these equations have to be true. Can't lie, I took it to heart. Wait, which bit? J'ai vu un prix? I never learned French at school, okay? I did Spanish and German. Anyways, if I rearrange equation 2, I can get that q is equal to 1 over 2k by just dividing both sides by k. Wait, what did you take to heart, by the way, Hybrid? Ich habe Apfel. Oh. Parlez-vous le français? I'm assuming that means you're from France, but I don't know. If so, I apologise. Okay, and then I'm going to sub it into... So, Evie, you said... Sorry, yeah, Evie. Means, do you speak French? Well, as you can see, I don't. I speak Spanish, Portuguese, Greek, and English. I think you can answer this question without using simultaneous. You can. You're 100, so Sky King, you're 100% correct. The mark scheme jumps straight to the answer. So the thing I wrote before, that is another way to do it without simultaneous equations. I'm just trying to explain it fully. Yeah, so Evie, when you said you kept getting equals to 1, what that means, and with any simultaneous equation, if you keep getting the answer, you just get 1 equals 1 or something useless like that, it means you subbed into the same equation that you rearranged, which is it's a big naughty, not very good. So I get 3 equals, q is now 1 over 2k, k plus 2. So expanding the brackets, I get 1 over 2k times k would be k over 2k, plus 2 over 2k. So I can cancel out k from this fraction and 2 from this fraction. I'll do this really slowly just to make it hopefully make sense. Why are you not telling me that 3 hours ago? I didn't know. Minus a half from both sides. And I get 5 over 2 equals 1 over x. Here's a little cheeky secret. If you just have a fraction equal to another fraction, you can just flip them both, which means x is equal to 2/5. If you'd like. If that last part doesn't make sense, then you would just times x up, times by 2, divide by 5. Does anyone need me to show you that, to go from here to here? It's such a nice question. You might be alone in thinking that, ice cream. You might be alone. Whew. So, from the mark scheme, yes, you're right, I changed it to an X. You're right, it should be K. My bad. I changed the letter. You're 100% correct, it should be a K, not an X. I couldn't read my K and I wrote X instead. No, it should be K. That was mid, yeah. Hey Ma, how are you? 1 mark for me, yep. So, I actually don't know what would happen there if I just change it. Please answer your question. Oh, I will towards the end. Oh god, we only have 8 minutes? Why? Alright. Let's see if we can do another question. Oh, you emailed it, okay. Actually, let's do another question of this and then we'll go through it because I feel bad otherwise. We haven't really done that many questions. We've done about 6 or 7. Another 5 marker. Okay. It's not mine though, so I don't have answers. That's okay. That means you won't tell if I'm wrong. Okay, that question was horrible. Yeah. Oh, both of you sent me questions. Okay. Does anyone need help solving simultaneous equations when they look like this? If not, I've been sent in 2 questions from people just now. Yes. Ah. I was hoping you didn't say that. Ooh. No, I'm kidding. Okay. So, how to solve quadratic. They're easy? Well, to be fair, this one's a bit of a pain in the backside. To solve quadratic simultaneous equations, you have to use substitution. You can't eliminate. So you have to rearrange the linear equation. So in this case, I might rearrange it for y. So 7 minus 3x. No, God no. So Lila, I'm glad you said that, but that is the most illegal thing you've ever suggested we do. You cannot square root this. Now you might be thinking, why? Well, simple. Difference of 2 squares. Ooh. That wouldn't really help. Ooh, actually. Oh no, you can't. Because you have equals 9. Yeah, you can't do that. Equals 9. So yeah, you can't square root when there's an add or subtract between the values. And the reason for that is 2 squared plus 3 squared square rooted does not equal 2 plus 3. Same with subtract. That's it's illegal, okay? They don't equal each other. Dots. So yeah, all you do then is sub that in for y, do a ton of algebra, use probably the quadratic formula or factorization, and you'll be able to work it out. You know, there are some really good questions in this paper, I think. Okay, what we'll do is we'll do the questions from Lila and Evie. Next week we'll do part 2. So I'm going to rename this. I'm going to call it part 1. And next week we'll do part 2 because... Can you recite Pythagoras' theorem to the nearest... I'm just going to say no. Whoopsies. Right. So we'll do the 2 questions from the people in chat. Then next week we'll do part 2 because I have a feeling there are some other really good questions in here. We'll do the simultaneous equation and we'll do the rest of the paper. Oh, did Piers Morgan say that? Interesting. Okay, we'll do Lila's question first, just because it appeared in my inbox first. Whoa, what on earth? Okay, I saw a bunch of circles there. That looks interesting. Where'd it go? I'm not trying to stall, I promise. Alright, I need to download this, I guess. There we are. That's weird. In an office, there are twice as many females as males. So, the way I would write this out is F to M, female to male, is 2 to 1. A 2-way table. You can use 2-way table, I guess. A quarter of the females wear glasses, 3/8 of the males wear glasses, 84 people in the office wear glasses. Work out the number of people in an office. Okay, so the way I would do this, how would I do this? That's a very good question. So, okay, the way I would probably do this one, Lila, is if I'm working out kind of the fraction of the males that are doing this, the first thing I'll do is work out this as a fraction. So, for males, it means that 1/3 of the people are men. For the males, 1/3 of the people are men. And for females, you have 2/3. 5/8 is worth 84. How did you get 5/8? Probably not. Oh, hang on. Oh, I see, you doubled this. Not quite. Not quite. Because it's 3/8 of the males and 1/4 of the females, so it's not quite the whole thing. And I'm doing a bunch of complicated stuff, then got all the way back to 84. Okay. The way I would work this out, and again, I'm a bit of a lunatic, is to work out the number of males that wear glasses, you would have to do 1/3 of the total number of people times the fact that 3/8 of them are wear glasses. So 1/3 of the total number of people would give you how many men, and then times 3/8, because 3/8 of the men wear glasses. Does that make sense? And for the females, the women's, 2/3 of the total are women, times 1/4, because 1/4 of the women are that. Does that make sense? Could probably have put this in a bit of better order. So Lila, and okay, yeah, cool. So it says 84 people wear glasses, right? So if I add these two things together, I should get 84. So am I actually no? Forget it. This is a grade 9 question. I have no idea. This looks more like a grade 6 or 7 question. It's just ratios. So probably a grade 6 question. It's just a bit of a painful one. Yeah. So if I times this out, I can cancel the 3's from here, and I can cancel this, make it 2. So we get 1/8x plus 1/6x equals 84. Is a paper 1. Okay, so we have to make these the same now, the denominators. So times them by 3, just times them by each other. Top and bottom by 6, top and bottom by 6, and top and bottom by 8. So 6/48x plus 8/48x equals 84. 6 plus 8 is 14, so we have 14/48x equals 84. Is there anything clever we can do? I mean, I probably can't. I could simplify this down again. divide both sides by 7. So then I have 1 over 24x equals 12. Oh, that would be better, yeah. Maya, well done. If you times them by 3 and 4, you could get 24. I just didn't spot that, but you're correct. 100%. And if you notice, I ended up with getting over 24 anyway. So you would have jumped straight to this part, which is quicker. But perfect, well spotted. And then times both sides by 24. So 24 times 12, so if you times it by 10, it's 240. Add another 48, will be 288 people. I hope. And now I get to do... Oh. Alright. Jesus Christ. Alright. This next question comes from a masochist that hates me. Okay, yeah. So, wait, I changed the title to part 1, right? Yeah, okay. And then we do part 2 next week. OAB is a triangle. Okay. Q is the point on AB. What's that? Okay. Three hours, yeah, well, I'm a madman. So, AQ to QB. Okay, that gives me a bit of a help, right? So all I want to do is work out... Okay, that's fine. Yeah, this is fine. What is a vector method? So essentially you just need to use the same thing that we did earlier. That's a vector method. So OQP is a straight line. So O to Q and O to P. Okay. So that means OP is equal to some letter. Did they use the letter K yet? No. So I'm going to use the letter K. Oh. Okay. So that's the first thing I would do. Again, because OQP is a straight line, then the vector OP is a scale multiple of OQ. That's the first thing I would do. I mean, yeah, it probably is, yeah. I don't know, I haven't done it yet. So now we're going to work out what this is. So first of all, work out OP. I think that is the easiest thing to do. So OP is equal to OA plus AP. Right? And it tells me what that is. It's 4A plus 2A plus 8B. So in other words, it's 6A plus 8B. Yeah. Okay, so far is everyone with me? I've never seen this question before, so if I get it wrong, I'm deleting my YouTube channel. But, okay, that should be fine. Now I need to work out something for OQ. Good. Perfect. Q. My brackets kept it being impossible. Yeah, lol. Okay, cool. You know, this is actually a really similar to the question we did earlier, if you actually think about it. So what I'm going to say something quite brave, right? Is, well, first of all, okay, I need to work out OQ, right? That's the other thing I need to work out. And to do OQ, I'm going to do O to A plus A to Q. Now, I don't know what AQ is, but I know that AQ is a fraction of AB. So, again, pick another letter. I'm going to pick Q because I chose it earlier. And now I can work out what AB is. It's just going to be minus 4A plus 6B, right? You literally did this, did you? Well, you might be right. Who knows? Again, please stop me if I'm not making sense. When I see a maths question I haven't seen before, I get a bit invested, which means I might like go long periods without talking or something. I'm also a very proud man, so if I get this feel like I'm getting stuck, I might panic. But so far, is everyone okay? I hope so. I've noticed the view counts start dropping, so I've got a feeling people don't really want to see me do vectors, but that's fine. That's fine. Yes. Doing OP minus OA. Ooh. No. Wait. No. You couldn't. You did this as well? Okay. Yeah, cool. I'm going to factorize out the A again because I want to. Also, I saw you write vectors are fun. I am in agreement there. Okay, so I have an expression for OP and have an expression for OQ. Vectors don't make sense. Well, during my 3 hours. Yeah, vectors are fun. Okay, so OP, I'm going to sub this in now. So we get OP, which is 6A plus 8B equals K, whoopsies, times OQ. So if you notice, this is really, really similar to the question we did earlier today. And that's the kind of beauty of vectors. It's that the questions are really the same all the time. Oh, they're goofy as hell, yeah. I will say, just FYI, for those of you that are going to like do A-level maths or something, this doesn't come up. Vectors come up in A-level maths, but they're nothing like this at all, because this is not a real-life application for vectors at all. I've gone on rants many a time on these live streams where this is pointless. You don't need to know how to do this. The vectors you learn in A-level maths are they make more sense because they're real. They exist. Yeah. Yeah. So the ones you do in A-level maths, they're actual real vectors. They're real applications. They will make 100 times more sense. This is a load of crap, basically. Okay, then I'll expand. I'll do literally the exact same thing as I did before. And yes, we will be doing simultaneous equations. I saw someone ask that question. I'll just rip up the paper and scream in the example. Fair enough. And again, just like we said before, everything in front of A should be the same. And everything in front of B should be the same. It should be the same, so to speak. Okay, so if I compare A, we have 6 equals K, 4 minus 4Q, and for B, what have you done? That's a very good question, Evie. Okay, so what am I actually trying to work out? Okay, so in this case, I'm actually working out what Q is, because Q is going to give me the ratio from A to B, from A to Q and Q to B. Okay, that's what I need. So I'm actually going to try and work out what Q is, so I'm going to eliminate K. So K is equal to 8 over 6Q. So I can cancel top and bottom and I'll get 4 over 3Q. Sub that into this equation and we will get 6 equals 4 over 3Q. 4 minus 4Q. Expand out the brackets. Oh boy, I love algebra so much. 4 over 3 times 4 would give me 16 over 3Q. This is going to be a disgusting number, by the way. Right, cancel out the q's. Plus 16 over 3 to both sides. So 6 is equal to 18 over 3, right? So we have to do 18 plus 16, which is 34. So we can actually cancel out the 3's as well. Oh. Yeah, so we have 34. So why am I adding 16 over 3? Because I want to... This is 16 over 3, right? And I want to move it to the other side to work out what q is. Alright, fine. So that means q is just going to equal to... Actually, you know what? I'll do it in more steps, because... So we have 34q. Is this still a paper 3 question? I actually don't know what paper this is from, but it could come up in paper 3. Eight over 17. Okay? So what was q again? Q was a to q. So I know that a to q has a ratio of... Was it 8 over 17? Yeah. And if you remember, to turn ratios into fractions, all you do, AQ will be the top number, and QB will be 17 minus the top number, which is 9. So the answer should be 8 to 9. Vectors are the worst topic on the syllabus. On that, we are agreed, Maya. Okay, we overshot by 15 minutes. How do I know when to flip a ratio? What do you mean by flip it? Like A to B is 3 to 4. Yeah. Yeah, I don't like doing that. Basically, if I have this, then the way I do it is the division between A and B should be equal to 3 and 4. So when you cross multiply, it will always be 4A equals 3B. I would always do this step, this additional step, Evie. Then you won't make mistakes, ever. So it's always true. Yeah, this first thing here is always true. You're very welcome, Maya. I hope you found it useful. And we'll be doing this again next week. And yeah, so just so you're aware before everyone leaves, next week we'll continue with paper 3, because I think that we've done some really good questions here, and there's probably a few more that are quite good. And yeah, and if you have any suggestions, just leave them in the chat or the comments, and that'll all be good. But other than that, enjoy the rest of your week, because it's half term. Hopefully you're relaxing a little bit. But I'll see you next week at the same time, okay? See you later, Ma. You're welcome. So, because my answer was the wrong way. You're very welcome, Lila. Like, my answer was 5 to 6 when there was 6 to 5. You're very welcome, ice cream. Thank you very much, Maya. Bye. So, what's this? So, from an AQA question.